Hello class, welcome to another session for General Chemistry 2. So here is a review of our last activity entitled Expectations. I hope that you already submitted your outputs. The following rubric shall be adopted for the evaluation of your outputs or your submissions. 15 points if you shared completely as a learner your expectations based on the instruction within the allotted time. In a 3-minute video or audio recording. For 10 points, you have shared your expectations, albeit not entirely, or an incomplete sharing of expectations. For 5 points, share some of your expectations. So let's begin by describing the kinetic molecular theory of matter, or KMTM. According to our source, which is cited under this slide, the kinetic theory of matter, or the particle theory, says that all matter consists of many very small particles which are constantly moving or in a continual state of motion. The degree to which the particles move is determined by the amount of energy they have and their relationship to other particles. Most of the time, the energy being referred here is thermal energy or heat energy. In pertaining to the particles might be atoms, molecules, or ions. The use of the general term particle means the precise nature of the particle does not have to be specified. For example, when we are pertaining to atoms, for example, we might refer to oxygen atoms. While for molecules, we have water molecules, which is also made up of oxygen, with its formula H2O, 2 atoms of hydrogen and 1 atom of oxygen. For the ions, so these are the charged particles. They can be positive or negative. The cations or anions. Moreover, the particle theory helps explain properties and behavior of materials by providing a model which enables us to visualize what is happening on a very small scale inside those materials. As a model, it is useful because it appears to explain many phenomena, but as with all models, it does have limitations. So if you can remember, in biology, your teacher may have explained the DNA model. It's somehow similar to the KMTM model, in which the model allows you to visualize how how those atoms, ions, or molecules are moving in relation to one another, or the intermolecular forces, and also with the amount of energy that they have, or it's depending on the amount of energy that they have. Furthermore, the model can be used to help explain the properties of matter, solid, liquid, and gas, the basic three. and also what happens during physical changes such as melting, boiling, and evaporating. For example, if we try to visualize water in its three states, mainly solid, liquid, and gas. The solid mainly of ice, and also the liquid form, and also the water vapor in gaseous or gaseous form. So, by understanding the model or the KMTM as a theory, we would be able to explain the reason why they behave like that or why they have that characteristics. So even in your elementary days and your junior high school discussions, I think you have covered this one for solids, liquids, and gases. Let's just go over with the descriptions. In solids, the particles are held tightly and packed close together. They are strongly attracted to each other. That's pertaining to their intermolecular forces. They are in fixed positions, but they do vibrate. In liquids, the particles are fairly close together with some attractions between them. They can move around in all directions, but movement is limited by attractions between particles. In gases, they have little attraction between them. They are free to move in all directions and collide with each other and with the walls of a container and are widely spaced out. So among the three states of matter here, or among the three forms of matter, we can say that in terms of being compact, we can arrange the different states of matter beginning with the most compact being solids, followed by liquids, then gases. In terms of the amount of attraction between each other or between the particles, remember the particles can refer to atoms, ions, or molecules. So in terms of the greatest attraction between them or the intermolecular attraction, the greatest attraction exists between solid particles. For example, the iron atoms in an iron nail. So they are very compact. Then we have the liquids followed by the gases in terms of the attraction between them. In terms of being able to move from one place to another, as we all know, we are all aware that solids do have fixed positions, but at the atomic level, we can visualize them as vibrations or producing vibrations, which is related to the concept of sound. That's why most of our audiovisual apparatus or appliances are making use of solid metals and solid materials to be able to produce sound through vibrations. So in terms of liquids, they can move freely. I mean, they can move around or flow, but they are limited because, for example, you have your river. The attractions between water molecules in the river are strong enough so that they are still limited by the attractions between the particles, or in the case of water in the river, between the water molecules. For example, in the gases situation, so we can relate it to the concept of using our perfume. When you use a perfume or whisk it to your body, it or the molecules inside it moves freely around the environment and they collide with each other because they have very little to no attraction between its particles. So let's now go on to our visualization of the KMTM model or the KMTM theory. So as we can see here at the leftmost portion of the picture, we have the solids and the liquids, followed by gases. So from the description of the different states of matter, solids, liquids, and gases, using the KMTM model, can now arrive at the following properties of matter. For solids, they have a definite shape. They can also maintain that shape because of their rigidity. They are difficult to compress as the particles are already packed closely together. They are often dense as there are many particles packed closely together. Next, for liquids, they do not have a definite shape. They flow and fill the bottom of a container. They maintain the same volume unless the temperature changes. They are difficult to compress because there are quite a lot of particles in a small volume. They are often dense because there are quite a lot of particles in a small volume. Lastly, for the gases, they do not have a definite shape. They expand to fill any container. They are easily compressed because there are only a few particles in a large volume. And they are often low density as there are not many particles in a large space. So let's focus on our density here. So density can be measured by the amount of force applied per unit area. Okay? And that usually refers to solids. They are the most dense because of their packed or rigid arrangement, followed by liquids, and lastly, the most compressible or the least dense are the gases. So it's another activity time. We have activity 2 for the kinetic molecular theory of matter, or the KMTM, which we have discussed earlier in our session. So just like in our previous activity, please submit your outputs via email at glenmichaeljameson.picaro@ed.gov.ph, or directly message your answers in the form of pictures to my messenger account. So for the directions, write your answers in a piece of paper, take a picture of it, and submit it through messenger or via email. Please read the following questions carefully and try to relate it with our discussions. Number 1, why do you think that the same volume of different materials have different masses? For example, comparing 1 cubic centimeter of gold weighs 19.3 grams, but only 2.7 grams when we are referring to 1 cubic centimeter of aluminum. For the second question, look at the picture in the upper right. Which states of matter can flow and which state cannot? Explain it using the KMTM and the properties of matter. Number 3. A group of STEM students headed by Kathleen encountered plasma in their chemistry laboratory. Can KMTM explain its existence? And for the last question, what do you think, based on our discussion and our activity, are the limitations of the kinetic molecular theory of matter? So that's it. If you have some questions to clarify or suggestions, You may contact me through my email or by messaging me through Messenger. Okay, that's all for our session. Have a good day.